We are in Unit 5. We are talking about systems of linear equations. This is day 1. We may only have 5 days of notes, maybe for this section. We will practice with this section for probably 3 weeks. So you might get a day of notes, and then we may practice for 2 or 3 days afterwards. Have I ever told you that before? No, right? I would love to say this is the easiest section in the world. I can't. What I find easy, you may not. So I will never say, and I have, and it's something that I need to change about the way that I talk to you. I find this section easy. Well, I'm also 33 years old, a math major, and have been teaching this for 12 years. If I don't find it easy, something's wrong. Would you agree with that? Most of you know how to graph correctly. If you know how to graph, the section will be easier than not. If you are still struggling with graphing, please, 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 please come in, see Mrs. Armstrong, see myself, because without graphing for the next 2 or 3 days, you will struggle. Okay? So, our first question that we should ask is, what is a system? And I just had this talk with another teacher the other day. And I will tell you honestly, the number of times that I have used systems in the real world have accounted to 1. I've used systems once in my life that hasn't been teaching. And you might say, Mr. H, why are we learning it? And I'd love to give you, well, in certain fields of subject, my wife is an aerospace engineer. She builds rockets. I asked her, I said, have you used systems? She goes, all the time. I said, who else uses systems? She goes, engineers. I said, anybody else? She goes, yeah, I'm sure there's some other science majors that do that. So you're still probably thinking, Mr. H, I'm not going to build rockets. Mr. H, I might want to be an interior designer. Okay. Folks, and I'm on video. Your parents can listen to it. School is not just about the information that you're going to take away and use in the real world. I'm teaching you how to think. If I can teach you how to think for yourself and how to reason through a problem, guess what happens when you go out there in the real world? You're going to learn how to think for yourself. If you don't understand something, you're going to be able to find out and work your way through it. Trust me, systems is going to push you to the limit on how to think. Okay? There are 3 different ways to solve systems. Each way isn't perfect. Each way isn't exactly... Some people find graphing easier, some people find a different way. We're going to quiz on each individual way, and then we're going to test. I'm going to break this down into small chunks. We're going to get it built, okay? But if you say, hey, Mr. H, am I going to use this in the real world? Probably not. Am I going to teach you to think right now for the next 3 weeks? Absolutely. I told you I don't want to lie to you. I don't think Caleb's going to go out there and be like, parents, watch me set up this system of equation for you at home. I'm going to solve our world's problems. He's not going to do that, okay? So what is a system of linear equation? Well, Evan told me what a linear equation was earlier. It's an equation that forms a line. What kind of line?
A straight line.
A straight line. System of linear equations. 2 or more equations that have one solution, no solution, or infinitely, this is why I don't spell infinitely many solutions. The key here is there's more than one equation that need to have the same answer. Okay, they need to have the same answer. So two or more equations that have one solution, no solution, or infinitely many solutions. There are three ways to solve systems. The first way that we're going to deal with is graphing. Underneath graphing, in parentheses, I'm going to put least accurate. It's the least accurate. You know why? Because if I'm graphing, just like on the test where I say, hey, you have to find exactly where it crosses through those crosshairs, it's really tough sometimes to see, is it exactly crossing through those crosshairs, or is it off by this little bit of a millimeter? If you're off by a little bit of a millimeter, that can be the difference between 7, 7 and 1/10, 7 and 1/1000th. It's hard to graph and be very precise. Does that make sense? The second way is substitution. What I have found, this is most kiddos' go-to. Substitution involves a lot of math. So if you're good at basic math facts, adding and subtracting, multiplying, distributing, substitution is the way to go. Personally, I don't like graphing. I don't really like substitution, but it's easy for certain problems. My favorite way is called elimination. And I call elimination, Nathan, I call you elimination! That sounds ridiculous. I don't know why you laugh, but thank you. I call it math magic. Because all about elimination is, now you see it, now you don't. We're trying to make something disappear. So it's math magic. Today, though, we are graphing. We will probably spend 3 days graphing before a quiz. Some of you will get bored. We will probably spend 5 days doing substitution, and we will probably spend 5 days doing elimination. This is going to be a long section, okay? I mean, it's going to be a long unit, but you're going to need the practice, and we're going to need to keep practicing, because no one problem is the same as any. So, let's see a problem, and I can show you what we're trying to do and explain what systems truly are. 2 or more equations that have one solution, no solution, or infinitely many. Today we're going to focus on one solution. I mean, we're going to focus on all of them, but we're going to really hit one solution hard. This is where you're going to have your graph paper. Okay? Systems are going to be shown with this bracket. And it's going to say y equals x, y equals negative x. I'm going to try to make this as perfect as possible because you've got graph paper. I do not, which means that mine might be off a little bit. I'm counting on you to help me. Can we graph y equals x? Can we graph that equation? What form is it in? Cody? Slope-intercept form. It is absolutely in slope-intercept form. Okay? I'm going to try to get a couple different colors because I want to make this easy for us to see. There are two equations, number 1, number 2. I'm going to label them so that I know so I do not get confused. Okay? I'm going to graph equation 1. So I'm going to say, okay, equation 1, m equals b equals. What is my b for y equals x? Isabella?
1 over 1.
My b is 1 over 1?
Oh no, you're 0.
Oh, b is 0. My slope, Cody? Okay, so let's graph that. I'm starting off at my...
Mr. H.
Yes, ma'am.
You mentioned that we needed to use this paper for more than a couple days. So
You should be in the top left box making the same kind of X and Y that I have.
but it's going to be small in this upper left box. You're not going to take up the whole
Correct.
area.
And if it's in the upper right box, that's fine too.
So we're not using,
You're not using your paper, and you're not using the middle. You're using the paper that I gave you. Thank you, I'm sorry.
okay, just so we know.
So now I'm graphing line 1 in this color. Might be a good idea to bring 2 different colors. Okay? So I start off at 0, 0. I go up 1 over 1. Have I lost anybody? This is where the ruler is important. Use your ruler. Draw a nice big long line. That's equation 1. Everybody good with me? I want to give plenty of time for us to get caught up. So it's important that you know how to use that ruler on your graph paper as well. This has to be precise. Mrs. Armstrong said math's very precise, especially today. Okay. Equation 2.
I don't know if they have a different color or highlighter to maybe just like put it in.
That would be a good idea.
Color.
Yeah, let's not worry too much about that right now. Let's
Okay.
get let's get them to see what an answer would look like, and then we'll go from there.
Okay.
So what's my m for this second equation? What's the m? What's my slope? David? Oh, negative 1 over 1, because it's a negative x. What's my y-intercept? Alyssa? What's my b for that second equation?
0.
0, good. Okay, so here we go. I'm going to start at 0, and I'm going to go down 1 over 1. Everybody with me? Did everybody see how I got those 2 points? There is one solution to this system. Can anybody guess why there's only one solution to this system? Looking at the graph, why do we think there's only one correct answer? What's happening with these two lines? It's only happening once, B.
Intersection.
They're only intersecting once. The goal of graphing systems is to get them to intersect. So the answer for this system is at the place of intersection. What ordered pair is it intersecting at? Look at your graphs. What ordered pair is it intersecting at? Maddie.
The origin,
Which is what ordered pair?
0, 0.
0, 0. That is the answer. Don't just trust it, though. Don't trust it. What should you do to make sure that it is? Check it in your equations. It has to work for both equations for it to be the answer. So I've got y equals x. This is x, this is y. Does everybody agree with that? That's an ordered pair. Substitute in 0 equals 0. Does that work? Does 0 equal 0? Oh, that's good. Let's try y equals negative x. Let's substitute in 0 equals negative 0. Is there such a thing as negative 0? So does 0 equal 0? Boom. When the graph intersects on a system, that is your solution. There's one solution if the graph intersects. It's all about graphing correctly. Questions on that one? We're going to do a couple more examples so that you can see these. Make a graph in the next quadrant. So set up your graph.
Mr. H, would you say as long as they have like 5 points above, 5 points below?
Oh,
5
that's more than enough for what
Fine,
we're
that's
doing.
fine.
Yep. There will be times that that might not be enough as you get farther in math, but right now that's going to be more than enough.
Sure.
So to make it easy, I would label it X and Y so you know where your ordered pair or where your graph is, right? Okay. How many equations do I have? 2. Are they in slope-intercept form? If they're in slope-intercept form, the easiest way to do a system is to graph it. This is equation 1 in green. This is equation 2 in red. Well, graphing rules stay the same. M equals, B equals. M equals, B equals. I still want you to know the slope. I still want you to know the y-intercept. Y equals 2x. What's my y-intercept in y equals 2x? Come on, I need some new people. I got Cody's hand up. Haley.
0.
0. So my y-intercept is 0. What is the slope? Go ahead, Ma.
2 over 1.
Very good. 2 over 1. Okay, Brooklyn. What's my y-intercept in number 2? 3. Good. Okay, we can take a look at our first example over here if we need some help with it. What's my slope? What's my slope? Nathan?
Negative. Negative 1 over 1.
Very good, sir. Negative 1 over 1. Do I have enough information now to make my graph? So again, your graphs are a lot more accurate. Why? Because your graphs have actually grids and everything else. I'm kind of making a graph. This is where a smart board would actually come in handy. we deal with what we've got. If you are confused, because I might have just heard somebody say, I'm so confused,
That was me.
please ask for some help. Raise your hand. Mrs. Armstrong can come over. I can help you. But don't just be like, oh man, I don't get it already. Because I want to be able to help you and eliminate any problems to start. I don't want you going into this feeling like, I don't know what I'm doing already. Okay, here we are. Oscar, can I now graph my green line? Do I have enough information to graph it?
Yeah.
Yeah. Where am I starting? On the Y, at what number? For my green line. 0. Here we go. So you're now plotting 1 and 0. My slope is positive 2 over 1. I go up 1, 2 over 1. And now, we're graphing. Is that hard? When I say is that hard, let me try this again. Was everybody able to do that? Is everybody able to follow along with what I am doing? Yes? Okay. I don't know why I keep moving that over there. Can we graph the red line now? This, Miss Graham. Where is my starting point? For the red one. That's my slope.
Oh, 3.
3. My y-intercept is b, so here I am. Okay, at positive 3 on the y-intercept. What is my slope, b? For the red one.
3. No, the slope is -1.
Yeah, the y-intercept is 3. The slope is -1 over 1. That means we go down 1 to the right 1. Notice how we're kind of overlapping points already.
This is totally different line. I need this line.
How many lines do we see on this graph? Hold up a number of fingers. How many lines do we see?
There you go.
Okay, so let's try this again. Everybody put their hands down. We're looking at this graph. How many lines have we just drawn? How many lines did we draw on this graph? We drew 2. We drew a green line. We drew the red line for our 2 equations. Do those 2 lines intersect? That means how many solutions are there to this system? 1 solution. The 1 solution is where they intersect. So look at your graph paper, because your graph paper is a lot cleaner than mine. Where are they intersecting at? What point do they intersect at? Cody. What is not rise over run? I need an ordered pair. Because the answers for these will always be an ordered pair. So, can I help a little bit? We're here. So, on my x, it's over 1. So my x value in my ordered pair is 1. What's my y value? Oh, 2. So the ordered pair, that's my answer, is 1, 2. Should I trust that? You have to check it. How did I get that? So, do you see where it's intersecting? Where the intersection is, we're looking for the ordered pair. So the ordered pair, you do your x first, which is 1. What's the y? 2. So my ordered pair, the intersection is 1, 2.
So at this point, at this stage of you're solving the problem, you are using just the individual point
Your
and
answer.
its location.
Yep.
Yeah.
Your solution is the intersection, and that's what you're going to use to check. We know that this is x, we know this is y. I'm going to bring this equation down. Y equals 2x. Guess what we need to do? Substitute in to check. My y is 2 equals 2 times what's my x? 1. Does that work? Well, 2 equals, what's 2 times 1?
2.
Oh, does 2 equal 2? So that solution worked for this equation. We need this solution to work for this equation as well. Let's check it. So the equation is y equals negative x plus 3. So y is 2 equals negative, I put parenthesis 1 plus 3. Well, negative 1 plus 3. What is negative 1 plus 3? 2. Does that work? Is this a good answer? Absolutely. Questions? Okay, you're going to try one on your own. Yes, you'll probably be confused. Yes, you'll need to ask for help. But listen, here's how I want you to do this. I want the whole table to talk it over. So here's what I'm doing. Haley, you're the group leader. Gracie, you're the group leader. B, you're the group leader. Emma, you're the group leader. Good luck. Cody, you're the group leader. Alyssa, you're the group leader. Okay? So you guys are going to talk it over. Make a graph right now in the third different quadrant. Here are our two graphs. Y equals 2x minus 4. Y equals x minus 2. Okay, so I should hear you talking. I should hear you graphing. I should hear you talking about slope, y-intercept, going through all of it.
So for the first value, n equals 2 over 1, and then b would be negative 4, right? Okay, so we have and then the second equation, n would equal 1 over 1 x, always equals 1, and then b would be negative 2.
Okay, so then we take this 2 and we put it in for y. Does 2 equal 2?
Okay, so
So that means
what did you guys do for it, and then you
our solution to this.
a pencil? Maybe.
You guys have questions as a group, ask.
Alright. So, for the first one, our starting point, which is b, is negative 4. And then it'll be 1 over 1. So go down to negative 4 and make a
Linear group, bud?
little dot.
He's doing his best.
And then since it's 1, you say 1 over 1? It's 2 over 1.
Oh, wait.
For the first one.
So you guys can talk to each other. So I'm gonna compliment this group up in the left-hand corner here. You guys are doing awesome. I can hear people talking, I hear math language, I hear where you start on the Y.
That's great.
That's awesome. That's what we should be hearing. All the tables, talk to each other. You're walking each other through this.
And number 1.
So,
So, we're going to draw a straight
I
line.
fix this.
And don't put the arrows. And then
Are you guys talking through this?
we work through this problem together. So, that's the first one. And then the second one, our G, first starting point is negative 2. So we'll go down to negative 2 and make it all this way. And then it says 1 over 1, so we'll go up 1 and then over.
How you guys doing?
Good, then just are you done drawing your friend?
Oh, that's, yeah.
Okay. So now I have to find n and b for both of the different what are those called? And then
Equations, yeah.
draw your arrow. So m is the fraction and b is just the starting point. So n is like in this.
What are you doing now?
So Well, we have the first one, M, what do you think it intersects at? Cause it's not a graph. Right, two. Yep. So we got this, but what do you say intersects
Well, you have to
at?
keep drawing it
And
until it
then B
intersects.
is the starting point, so it would be, yeah, it intersects at, this.
So now you're not gonna draw.
So 1/3. Right, I'll write one. 2, 3, 4, 1.
Extend them, you can't make them short. Extend
You
them.
guys remember, so it intersects at 3, 5, 1, you get what I'm saying?
Using that as a mathematical truth. Okay, just see what I.
Yeah.
I don't think 3,1's gonna be it.
Yeah.
Okay, so I know that most of us didn't finish, but I'd like to show you this example so you have it correct. Listen, 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 listen. You are confusing yourselves a little bit too much. Don't worry about the solution yet. You're graphing, but on the one graph, all you're going to do is graph 2 lines. You just got tested on graphing. Most of you did very well. So when I look at this equation, most of us can find m equals b equals. B is my -4, that's my slope intercept, or my y-intercept. My slope is 2/1. Show of hands. Who knew how to find those? Like, we know how to find that, right? Okay? Can we find, let's not even do anything else. Let's graph that one. -4, 1, 2, 3, 4. Y-intercept, up, 1, 2/1. When you graph this, this is important. Are my lines short? They're not little stubby things. I put my line down there. Maybe. And if I have to, I'll graph a nice big long line. Is everybody with me there? That's graphing. We've been doing graphing for 3 or 4 weeks at this point. This one. M equals, B equals. Well, my B is -2, but we don't have a number with the X. How many X's are there, Haley?
1.
1. So that's really 1, but we know that slope has to be a fraction, which is 1/1. So now I'm at -2. Up 1, over 1. Watch what happens. Up 1, over 1. Up 1, over 1. Wait a minute. Let's see. Oh my goodness. Oh my goodness. Wait a minute. Now that we have both graphs on there and both lines are long, can we find a solution? Well, the solution is where they intersect. This, don't go anywhere, don't pack up. This is my solution. At 1, 2, 3, up
Evelyn
1.
Fanwell, Liam Cox, to the office, please.
We will spend some more time on this tomorrow. Have a great, safe day, kiddos.